Hello, welcome back to Cracking the Cryptic, and a puzzle by Derek Leclerc today, who's proved to have the better of me to an extent in the past, and we'll see if he does today. It's a sort of mathsy puzzle, I think, called Square Pairs. I'll tell you the rules in a moment and we'll have a go at it together. Of course, there are our Patreon site where you can watch videos on crosswords, connections, gridogram and others. I accidentally put up a video of gridogram which included a couple of connections the other day, so sorry about that if you're following those. And there's other videos on Patreon, and of course we're coming up to the first of the month, which will be a new Sudoku hunt. And what else have we got going on? We've got all of our apps which feature line Sudoku. No lines like this though. And Classic Sudoku 2 and the Worms, including Blobz' latest masterpiece, Eclectic Sudoku Worm. And we have, of course, got some merch. Thank you to Marty Sears for the Rat Run designed merch, which is the latest additions to the range. And check it all out on the links under the video. But the first link is to this puzzle by Derek called Square Pairs. And the rules are as follows. Normal Sudoku rules apply. 1 to 9 will go in every row, column, and every 3x3 box. Adjacent digits along a line sum to a square number. So those two will add up to a square, and those two, etc. That is intriguing. I mean, I'm assuming that rule means every 2 adjacent digits and not also every 3 and every 4, because I don't think that could be fulfilled. Anyway. So I think it means that every 2 adjacent digits along a line sum to a square number. Let's get cracking. Okay, I think, and experience may prove me wrong, that the way to start this is to consider the square numbers that are relevant. So let's aide memoir those down, down this right-hand side. So 4... I'm leaving out 1 because no 2 numbers can add up to 1. 4, 9, 16, and that's it. Those are the only numbers we have to consider because 2 numbers next to each other, even here, 18's the maximum. Right, so that is going to give us 1, 3 as a possible pair. 9 gives us plenty. 1, 8, 2, 7, 3, 6, and 4, 5. 16 only gives us 7 or 9. So these are the possible pairs that we're looking at as pairs on the square pair red lines. And I'm then going to focus on the overlaps where we have to have different digits on either side of a number, because surely that number has to be 1, 3, or 7, which each appear in 2 different pairs. Is there any number that doesn't appear at all? No. Okay, so that's what we learn. Right, bye-bye aide memoir. So I think that cell, both of these and the 4-cell line is going to be where I really start. All of these numbers that come in between 2 other digits that see each other, they have to be 1, 3, or 7. Now, this has to be a pair made up of 1, 3, 1, 7, or 3, 7. Only one of those gives a square, and that's 1, 3. So that's what these must be. And then on the ends of the line, 1 is going to go with 8, and 3 is going to go with 6 to make 9 pairs. So we have a 1, 3 pair in this row and a 6, 8 pair. And this is the row where we get the given digit as well, which is 5. So everything else in the row is going to be 2, 4, 7, or 9. Now, what can this be on a red that's connecting with another cell? Yes, do you know what I missed out in that list of squares? I ignored these 2, which can have the same number twice, because the 2 numbers don't see each other. So what I missed out there was 4, 4 and 8, 8. As pairs making up the even pairs. No, 4, 4 is wrong. Sorry, 2, 2 equals 4. 8, 8 equals 16. So I'm going to have to bear that in mind as a possibility for these. Luckily, it didn't change any of my reflections about the 3 or 4 cell lines because they didn't include lines that skip between digits that don't see each other. But I didn't think of it, and I've thought of it now. Now, when we're considering this pair, 1 can go with either 3, not available here, or 8, not available here. So no. Computer says no to 1. 3 can go with 6 or with 1. But neither of these can be 6 or 1. So I think we have a 7 in this cell. I'm going to take 7 out of these. Now 7 can go with either 2 or 9 here and make 9 or 16. In fact, 2 and 9 are the digits 7 goes with. 7 goes with, so the other end of that line is also 2 or 9. Now, there isn't any number that can't go on any red line, so no good. I don't know what to do about the other digits in that row. I could think about this one, but I think there's a lot of options here. Maybe I ought to think about this pair now, because maybe one of those has ruled out one of the pairs. 1 can go with 3. 3 can go with 6. 1 can go with 8. Well, these others could be from 6 or 8, or 1 or 3. And in fact, I think one of them has to be from 1 and 3, because if that's a 3, you can't put 6 and 8 on either side of it. You can put 6 and 1. If that's a 1, you can't put 6 and 8 again on either side. You have to put 8 and 3. So 1 and 3 are definitely going to be used there. And then, the same might be true there, but that could be a 7 going with 2, 9. Okay, 1 and 3 have been used in this column, as have 2, 9, 7. Everything else in the column is 4, 5, 6, or 8. Now we've got this pair. From this pair, we can ignore the 2, 2 and 8, 8 possibilities that I latterly thought of. We're going to have to stick with one of the original pairs, and we can't use a 7 in this row. So that's going to rule out 7, 9 and 7, 2, but there are still 4 possible pairs. I don't want to mark that up particularly. Okay. What about, oh no, I was going to say, does 2 or 9 not being, 9 can't go here because 9 has to go with 7. So I'm going to rule out 9 from that cell. I don't think I'm going to get much, well, 2 can go with 7. Is there anything else 2 can go with? Only 2. No, I'm going to rule out 2 as well. So actually this cell does come down to 4 or 7. 4 will go with 5. 7 will go with 9 as options. Now, if that was a 7, this would be 9, and this digit couldn't then be 7. In fact, we've got 2 of these in the row. This one, one of them is going to have to be a 7. They can't both be 1 and 3, or this one would need another 1 and 3 operating alongside it. And that would be 3, 1 and 3s in the row. So one of these 2 digits is a 7 and is going with 2, 9. Oh, well, this one isn't a 7, it's in a box with a 7. There we go. That's a 1 or 3. So 1 and 3 are in these 3 cells, and that digit has to be a 7 and surrounded by 2, 9 on its line. And now this digit can't be a 9. That's a 5. This is a 4. That doesn't resolve this one. But now look, we've got a 2, 9 pair looking across the middle row. Okay, this 1, 3 line is very similar to that. It consists of digits from 1, 3, 6, 8, including both 1 and 3. Oh, I've got a 1, 3 pair in this column. That really is going to limit this a bit. It obviously stops it being 1, 3, but also 1, 8 and 3, 6. That leaves it to either be 4, 5. That's impossible because all of these 5 cells would be from 4, 5, 6, 8, and those are only 4 numbers. So bye-bye 4, 5. 2, 7 or 7, 9. So there's definitely a 7 here again. And that's a 2, 7, 9 triple now. So the other digit from 1 and 3 is going to go in these cells, and I'm starting to wonder if I'm going to end up colouring something. Now, 1 and 3 have appeared there. So again, this one is a bit like that. It can't be a 1, it can't use 1 or 3, and therefore it could be 4, 5, or no, yes, 4, 5, or 2, 7, or 9, 7. And I wish I could narrow it down a bit more than that, but this time I don't think I can, because I don't have this quintuple that I was looking at before. I've got this one in the top row. Either this is a 2, 7, 9 triple, or 1 and 3 are both on it. That's what I'm learning. If that was a 2, 7, 9 triple, this would have to be, I think, a 4, 5 pair. I feel like I ought to start trying to do 7s in the grid, actually. There's a 7 in one of those cells. Since I've placed a massive 2 instances of the digit 7, and I've got 1 definitely here, so that digit can't be a 7, and there is a 7 in this group. I don't think I have enough info, actually. If that can't be 7, that probably means this can't be 9. Yes, it does. Does it also mean this can't be 2? Yes, it does. I don't know what that does. It doesn't change the outlook for the top row group. Oh, we've had 2, 9, 7, 5, 4 in that column. Everything else in the column is 1, 3, 6, or 8. Yeah, okay. So now, yes, that's important, because of them. Thank goodness I do, if anything, over pencil mark. Simon sometimes calls me pencil mark, and it's helped today. Because if this was a 1 or a 3, as we've seen from these other lines like that, this line would contain both 1 and 3 and some digit from 6 or 8. But that would mean that there were 5 cells in the row using only the 4 digits 1, 3, 6 or 8. That's not possible. So this is a 7 in the middle here. And as we keep seeing, that is surrounded by a 2, 9 pair. Now, this can't be 7, and I think that means this has to be a 4, 5 line. Oh no, I'm going to have to go and get some water. Sorry, excuse me for a second. Right, I did better than water. It's pineapple juice. Now, 4, 5 pair there. 2, 7, 9 here. That's 7 sees this cell and stops it being a 7. Sees these 2 and stops them being 7s. Right, I'll come back to you. I'll start with you. This is now in a 1, 3, 6, 8 group. It needs 1 and 3 on this line, so that digit can't be 1 or 3. And then in the other cell on the line, it needs 6 or 8, so this is now a quad of 1, 3, 6, 8. That digit becomes 4 or 5. Okay, I'm coming back to the 2 or 9 in this cell now. 2 always goes with 7. No, 2 can go with 2, and that's very important. 9 always goes with 7. So this digit is either 7 or 9. No, hang on, it's always 7. If that's a 2, no, it's 7 or 2, that's what it is. Why don't I actually listen to myself when I'm talking? Don't know. Okay, but this is now a 2, 7, 9 triple in the column. Is that resolved by this odd digit here? If this is 2, that's 2, that's 9, that's 7. But if this is 7, oh look, here's a 2, 9 pair in this row. This can never be 7. Is that right? Or have I got that? Yes, because of this. Yeah, that 2, 9 pair in this row is fine. So that's a 7. And now this digit is a 2, and this is a 2, 2 line, adding up to 4. That gives us 9 and 2 at the top. There's a 2 in one of these cells by Sudoku, I think. There's... what else have we got from that? 7s. That's 7... there's a 7 in one of those two. I'm almost willing to bet that this is going to become an 8-8 line, adding up to 16. But I'm not making that bet yet. That 2 makes this a 9. That makes the digit above a 2. Then we go to the front of that row and we get a 9. And above that a 2, which I could actually have done from looking at that 9 in the box. Now, that's going to give us a 2. This 2 has resolved 2 in the central box. That gives us 2 in box 4. Are we all done on 2s? Nearly, but not quite. Yes, we are, because we can place the 2 in box 3. And that places the 2 in box 7. And now here on this line, we can't go 2, 2, so we must go 2, 7. And the 7 gets pushed up into box 3 and box 1 and into box 8. This seems to be the only place for 7. In fact, I've just spotted a 1, 3, 6, 8 quad there. And that means this digit is not 1 or 3 because there's a 1, 3 pair. If that's 6 or 8, this isn't. And we've got a 1, 3 pair here as well. These are 4, 5, 9 because that's all that's left in the box. That can't be 4 or 5, so we've got a 6, 8 pair here. This digit can't be 4 or 5 because of that triple that I just wrote in. So it's a 1, 3 pair. This is 4 or 5, and this is 9 in the bottom row. And that's from 1, 3, 6, 8, and I don't know which. Right, that's good progress now. Still got a 1, 3. We've got a 4, 5 pair done in this column. We're going to need a 9. I know where it goes. Can we finish off 9s? There's a 9 in one of those. That seems to be the only place for 9 in box 3. Ooh, we're not going to be allowed a 9 on the line because we can't get a 7 onto it. That's the only accompaniment for a 9 on a line. So 9 goes there, and then down here, and that's all the 9's done. All our 2 7s and 9s are placed. I'm quite surprised we've got 3 lines completely still to try, but that's fine. Okay, what's next? 7. I said all the 7s were placed and I hadn't put the last one in, but they are now. This digit is from the 1, 3, 6, 8 group, but 1 and 3 are both on that line. So that is 6 or 8. One of these is 4 or 5, and the other one is 6 or 8. Okay, this pair now. It can't be a 4, 5 pair because that would break this cell. It can't be 2, 7 because of this and many other things. It's either 1, 8 or 6, 3. So again, it's from this 1, 3, 6, 8 quad. And now we've got the whole quad in the row. Now, there must be a low digit on this line, just as there is there. So this must be a higher digit of 6 or 8. That's a pair now in column 1. The other 2 digits there are 1, 3. We've got this 1, 3 pair, mandating that this digit be a 6 or 8. It's really approaching time for me to start colouring the 1s and 3s, but maybe we won't need to. I haven't thought about this line. Can't be 5, 4. I made a mistake here. I thought this line had to add up to 9. Let's go back on that. Right, when I filled in the possibilities, I quite rightly filled in 1, 3, 6 and 8. But I neglected the possibility of it being 1, 3. Oh, well, it can't be because of that. So everything I did was all right, but not quite for the reason I thought. So there is a high digit on this line. Now, that has to be from 4 or 5 to complete the row. Is it time? Let's colour. Let's colour 4s and 5s first, and then we'll try 1s and 3s, and maybe 6s and 8s as well. So, how far do we get starting there? No, we didn't get to that 4-5 pair. So that didn't really work for 4-5s. Let's try 1-3s. I'll go with violet and orange for the 1-3s. This is going a bit further, if I'm honest. Violet, that one has become violet. We need orange in one of those surrounding that. One of these has a colour, that has a colour. Okay, that didn't quite go all the way either. I am going to bother to do 6-8s as well, just because I can. Light blue and green. Let's see where we go with that. Light blue, green. There is a light blue, there is a green on one of these, so that's light blue. And that is already green. So there's a light blue on one of these two, and we can see where it can't go. So now it has at least proved the colouring was worthwhile doing. Because now I get a 1-3 there, but it's the 1-3 that goes with this colour of 6-8. So that's either a 1-8 pair or a 3-6 pair, adding up to 9. And they must always cleave together. So that goes violet as well. Now, violet and light blue are in this group. How do I use that? I think there's still some shenanigans to go in this puzzle. Let's have a look at this column. Violet is always surrounded by orange and light blue. That's these two colours. Oh, I hadn't noticed. There's a 1-3-6-8 quad, making this a 4-5, and therefore a yellow one. Now, there has to be a red 4-5 in this row, and now the colouring for red and yellow pays off, because we've found out where that is, and that does colour these ones down here. Then I can make that a red 4-5. I need one in this box and one in this box, a red. I also need yellow in that pair. Oh, I can't quite finish off the yellow 4-5s. That's surprising. Right, there's a red in one of these cells, and the other digit here is a 6-8 in green, isn't it? Are these green and orange? No, what are these? Light blue and orange. Oh, they are resolved now, because light blue sees that. So violet is always surrounded by light blue or orange, as it is here. And this one can't be light blue, so it's orange, and now we know it's a 1-3. This must be a 6-8. I'm colouring it light blue. We need an orange in this set, so it's got to be there, since it's 1 or 3. Then it's here in box 1. And now it's got to be here in box 3. That's orange. The violet can't be here, so it must be here. So that's where the 1-3 is. This is the 6-8. And orange tying to a 6-8 always ties to green. So that's what that is. This, to complete the row, is a 4-5 in yellow. Now we need a 4-5 in yellow in column 5. Oh, I still can't put one R, and that's looking at this digit 5, which has gone red. So then I can colour now I can disambiguate all the reds are 5s. I could even put the last one in before I do it, so I can fill the whole grid with 5s. Then the yellows become 4s. I haven't got them all. Let's see if I can do... No, I can't do the last two. We'll get to those. Now, has that helped any of my lines? Not really, because they're all 1-3s and 6-8s. Let's just get rid of the corner marks. Okay, so this, to complete the row, is a 6-8 in green. Now, what's that going with here? That's going with a 6/8 in green, the same digit, and they are a double 8 pair, which was about what I expected. So I'll put in the last one and then highlight all the greens and colour them 8, and that line adds up to 16. Now we know that light blue is a 6. Now that goes with violet as a pair, so violet is a 3 to make that pair add up to 9, and orange is a 1. That got us a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight. So let's get rid of all of the colours in the grid, because they've done a super job and we just need to finish with numbers now. 1, 8 there. This is a 3, 6 pair. This is a 6, 4 pair. Don't know the order yet. 1, 3, 4 and 6 in this box. So let's mark up the candidates and then we will finally... Oh no, that has to be a 1. Oh, it didn't quite go as I thought. 6 could be in any of those. But now we can finally look at this line. Well, it can't be 1, 6 because 7 is not square. So 1, 3, and then we go 6, 4, 3, 6, 4, 6. What a lovely puzzle by Derek. That is just really elegant and classy. And I think the colouring was necessary. Do let me know if you did it without colouring and how it worked in that way, if you did. I suspect you didn't. I suspect you had to colour. Very clever puzzle, Derek, and I really enjoyed that one a lot. So thank you for watching us on the channel. Such a pleasure to have you with us every day, tackling these variant Sudokus and the logic problems they set. Sometimes it's a tiny bit of maths or arithmetic. I was very shocked the other day when one of the comments on the puzzle that involved base 3 asked me to explain base 3, and I'm going to take that on board and try and explain concepts that might not be known. I'm assuming today everybody knew what a square number was, that it's a number multiplied by itself. There, I think I've just proved I failed to take that comment on board, but anyway, done it at the end. We'll see you again next time. Thank you for watching and bye for now.